Good morning, everyone. Welcome to Tuesday, March 24th. Today we are going to be continuing what we did yesterday, which was factoring the greatest common factor, or the GCF, out of monomials. Today we're going to be factoring out the GCF of binomials and maybe even some trinomials. So grab your paper and pencil. We're going to start with a warm-up. So your warm-up for today, you're going to write down this sum, 8 plus 12, and this difference, 24 minus 16. Now notice I classified this as a sum, this as a difference. We know that from CC3. What I would like you to do is I would like you to take this sum and turn it into a product without actually simplifying. So we know 8 plus 12 is 20. Can you write this as an equivalent product without simplifying? Same thing over here. We know 24 minus 16 is 8. Without simplifying, can you turn it into a product? And I'll give you a hint. It has to do with the distributive property. So go ahead and pause the video, give that a shot. And if you were confused, then here's what I mean. To turn something into a product doesn't mean to turn both terms into a product. For example, if you wrote this as 2 times 4 plus 12, even though you've taken the term and turned it into a product, the entire expression itself is still a sum. So that's not what we're trying to do. We're trying to take this entire expression and turn it into an equivalent product, meaning something that still equals 20. Now, what does this have to do with the GCF? Well, one of the ways to do this is you find the GCF, the greatest common factor, or just a common factor of 8 and 12. So when I'm looking at 8 and 12, I realize that they're both divisible by 2. So if I were to factor out 2, remember what we did yesterday, factoring out means to write both of these as products using 2. In other words, 2 times 4 and 2 times 6. 2 times 4 is still 8, 2 times 6 is still 12. But this isn't a product. It's equivalent, but it's a sum. How do I change this into a product? Well, it has to do with the distributive property. Notice how 2 is a common factor. So what we can actually do with that, it's kind of cool, is we can take that 2 and make it a factor out on its own, open up a group, and inside that group, we can put the second parts of each factor, 4 and 6. So what we've essentially done is we've taken 2 out of 8, which leaves us with 4, and 2 out of 12, which leaves us with 6, and we're multiplying it out in front. Now, how do we know this is still equivalent? Let's do a quick check. What is 4 plus 6? 4 plus 6 is 10. And what's 2 times 10? Still 20. So this is called factoring. Factoring means take something that is a sum or a difference and turn it into a product. Now that you've seen the example, I want you to take this one, the same expression, 8 plus 12, and factor it using a different factor. So instead of using 2, what other factor could we use? All right, a factor that comes to mind for me is 4. 4 goes into 8 and 4 goes into 12. So I'm going to do that same process, but now I'm going to do it using slightly different notation. What I'm doing here is I'm going to take 4 out of 8 and take 4 out of 12. That 4, because it's a common factor, will become the first part of my new product. 4 times whatever I have left. Now notice these look like quotients now, right? Because when you're actually taking something, when you're removing a factor, it's almost similar to division. So what am I left with when I take 4 out of 8? 8 divided by 4 leaves me with 2. And 12 divided by 4 leaves me with 3. Now, is this still equivalent? Well, let's see. 2 plus 3 is 5. 5 times 4 is 20. These are equivalent expressions. The only difference is this is a sum, this is a product. And this again is called factoring. So now that you've seen one example, I want you to go ahead and try to factor the second expression. 24 minus 16, which we know has a value of 8. Can you factor it? Meaning, can you take that difference and turn it into a product? Can you find a common factor? All right. Now 24 and 16, there's a lot of different ways to do this. Rather than go through the entire process, I'm gonna do this a little bit quicker. So the first factor I know 24 and 16 have in common is 2. So if I were to factor out 2, what would I be left with? Well, 2 times what is 24? 2 times 12. Maintaining subtraction, 2 times what is 16? 2 times 8. So that's one way to change it into a product. Now let's multiply just to be sure. 12 minus 8 is 4. 4 times 2 is 8. So it's still equivalent. What else could I have factored out instead of 2? What about 4? Does 4 go into 24 and 16? I think it does. Let's take out 4. So now we're going to write another equivalent product. So this is one way to write it as a product. This is another way. 4 times what is 24? 4 times 6. And 4 times what is 16? 4 times 4. Now remember, it still needs to have a value of 8. If it doesn't have a value of 8, then we know we did something wrong. So let's see. 6 minus 4 is 2. 2 times 4 is 8. Still equivalent. Is there a third way to write this as a product? I think there is. I'm pretty sure 8 is a common factor of 24 and 16. So let's write it now using 8 as a factor. 8 times what is 24? 8 times 3. And 8 times what is 16? 8 times 2. 3 minus 2 is 1. 1 times 8 is 8. So all 3 of these expressions are products that are equivalent to this difference. And again, this whole process is called factoring. Factoring means take something that is a sum or a difference and change it into an equivalent product. Now, you might be looking at this going, why the heck are we doing this? Well, today in our practice, we're going to be looking at factoring binomials and some trinomials using what we learned yesterday, which was finding the GCF of single terms of monomials. So grab your papers and let's get ready to go. All right, so this is an example that you're going to see on your practice. We're factoring out the GCF, or the greatest common factor. So I have a binomial here. I have 20x plus 15. Binomial because it has 2 terms, its leading coefficient is 20, it has a degree of 1, all of those things we already know. So the first thing, in order to factor, again, remember, factor means write as a product. This is currently a sum. We don't want a sum, we want an equivalent product. And you're gonna think about distributive property here, like almost doing the opposite of distributing. We're gonna pull out a common factor, put that in front, and then what's left behind will be a group of some sort, just like our warm-up. Okay, so step 1 is we have to find the GCF. Find the GCF. We know how to do that from yesterday's practice. So I'm looking at 20 and I'm looking at 15. Hopefully we can get a little bit better at this today. So 20 and 15, let's see, a common factor that comes to mind, 20 is 4 times 5, 15 is 3 times 5, 5 is our common factor. Now we're gonna find the GCF, meaning that we start with finding the GCF of the 2 coefficients, which in this case is 5, but then you also have to look at the variable. This has an x, this does not, meaning that I can pull an x out of this term, but there is no x to pull out here. So my GCF here is simply 5. That's all I can take out of both monomials. Okay, second step, coming right up, is to factor out the GCF. This is where that practice that I encouraged you to do yesterday, where not only do you find the GCF, but you write them both as products using the GCF. This is why that's so important. So we're going to take both of our terms and we're going to write them as products using our GCF 5. So I'll write it out in a couple steps. So if we start with 20x plus 15, I'm going to take out 5, factor out 5. So 20x becomes 5 times, What's left over? Well, let's think about that for a second. 20 is 5 times what? 5 times 4. But then how do I get that x as another factor? I just attach it to the 4. Let's double check really quick. 5 times 4 is 20, times x is 20x. We're good so far. Okay, now maintaining the structure, because this is still a sum. We haven't changed it into a product yet. We're just changing each term into a product. Let's also factor 15 using 5. 5 times what is 15? 5 times 3. Now again, you might be looking at me like, what are we doing here? It is not a product yet. All we've done is we've factored out the GCF from each term. To turn it into a product, we need to have, if you remember from our warm-up, oops, there goes that, we have to have the common factor out in front, followed by a binomial or something inside of a group. So coming back to this, our common factor here is 5. So notice how both 5 is in both of them. So we're gonna pull out 5. And then what are we left with? Well, we're left with 5 times what gave me 20x? 4x. And because this is a sum, we're going to maintain that structure. 5 times what gives me 15? 5 times 3. So it's distributive property in reverse. We have now taken something that was a sum of 2 terms and changed it into a product of a common factor and a group that still has 2 terms. And that is called factoring. Now, you know me, we're never done with just that. We always check our work. We always multiply to check. It is so important that you multiply to check. I cannot emphasize that enough. Okay, multiply to check. Well, how do we multiply something like this? You can hear the vacuuming happening upstairs. We use the distributive property. So to multiply this to check, all I'm gonna do is I'm gonna distribute 5 to the first term and 5 to the second term. We've done this a million times, you've got this. What is 5 times 4x? 5 times 4x is 20x. And what is 5 times 3? 5 times 3 is 15. Again, all we did was distribute. 20x plus 15 is what we started with. That's a huge check mark, and that's how we know we did this correctly. All right, we're gonna look at another example here in just a few. All right, here we are, second example. We have a difference of 2 terms, 25x cubed minus 35x. We're gonna follow the same 3 steps to take this difference and turn it into a product, which is all called factoring. Here we go. Step 1, we're gonna find the GCF. Now, what stands out to me that's different from this example and this example is both of these have at least one x. They have an x in both. That right there is a red flag that my GCF is going to contain x. So here we go. Step 1, GCF. Okay, what number goes into both 25 and 35? They both end with a 5, so that kind of stands out to me. So 25 I know is 5 times 5, and 35 I know is 5 times 7. So that means that my GCF is going to contain 5. Now what about the x's? Well, x to the 3rd power simply means x times x times x. And then there's only a single x over here. Again, this is kind of like what we were doing yesterday. So how many x's do they have in common? I see 1 here and 1 here, meaning they have 1 x in common, so my GCF is 5x. Step 1, complete. This is the exact same thing you were doing yesterday. I want to make that clear. Now, yesterday you would have been done. Today, we continue. Step 2, we're gonna factor out the GCF. So we're writing both terms as a product using the GCF. So we're gonna start with 25x cubed. We take out 5x, and we're left with what? Well, when I take out 5, I'm left with a 5, and I'm left with 2 x's, which remember, 2 x's is not 2x. X times x is x squared. Let's do a quick multiply to check. 5 times 5 is 25, x times x squared is x cubed. Now, oops, cover that up. Okay, now maintaining that subtraction, which got a little bit messed up there, but that's okay. We're gonna write 35x using our greatest common factor, 5x. So this is 5x times, when I take out 5 and x, I'm just left with 7. Now, we factored both individual terms. We factored the first term, we factored the second term, but we haven't written this fully as a product yet. So our final step is to take out that GCF, that 5x, and that's going to be our first factor, 5x. What's left is the difference that when I apply the distributive property gives me my original expression. That's right here. 5x times 5x squared gives me 25x cubed. So my first term in the group is 5x squared. Maintaining the structure of subtraction, 5x times 7 gives me 35x. So my second term is 7. We have now taken something that's a difference, turned it into a product. So as far as factoring is concerned, we are done. But you know that if you were in my classroom right now, you wouldn't be done, because what would I make you do? I can feel your eye rolls through the computer screen. I would make you check. Yes, yes, yes. Always checking. Now, checking just means multiply it. Apply the apply the distributive property. Some of you will be able to do this mentally. Some of you will actually need to do this on a piece of paper. Either way, we're gonna check it. I'm gonna write it out this time. Okay, here we go. So distributive property just means multiply the outside factor by both terms on the inside of the group. 5x times 5x squared. Well, 5 times 5 is 25. And x times x squared. Let's think about what that means really quick. X times x squared. Well, remember, x squared is just x times x. That's all that that means. So really, this is saying x times x times x, which we can write as a power. X times x times x is x to the third power. So when we have this x times these two x's, that leaves us with x to the third power. That's how you multiply to get that first term. Maintain the subtraction. 5 times 7 is 35 times x, 35x. Let's see, is that what we started with? 25x cubed minus 35x. Check. We know that we factored it correctly. All right, we're gonna end things here with an exit ticket, and I'm gonna show you a couple more examples on that exit ticket. All right, for our exit ticket today, I'm going to have you factor, I changed it to polynomials, because we're gonna do a binomial here and a trinomial here. So the same 3 steps will apply. You're gonna find the GCF of both terms, which is what we were doing yesterday. You're gonna factor out the GCF of each term, and then you're going to write it as a single product, and then as always, you're going to multiply to check. So feel free to pause the video now if you'd like to try this on your own first. And here we go. So 5x squared, 20x. I know that they have a common factor of, I believe, 5. And then this is 5 times x, and 5 times 4 times x. They both have an x in common. Again, if you need to do the entire process, or if that didn't make sense, reference yesterday's video on how to find the GCF of monomials. I'm gonna move this over to the side here though. GCF 5x. Okay, step 1, complete. Step 2, we're going to factor out the GCF. Now I'm going to use 2 different colors here to help keep my ideas organized. So if I look at this term, this is 5. Now when I factor 5 out of 5, what am I left with? That's actually 5 times 1 times x times x. And then this is 5 times 4 times x. So if I factor out 5x from both terms, what am I going to be left with? Let's start with the first one. This is 5x times what's left over. Well, when I take out 5x, I'm left with 1x. So feel free to write that as either 1x, or think about your future Algebra 2 teachers. They're not going to want to see 1x. They're just going to want to see x, because we know 1 times x is just x. Maintaining the structure, this is still a sum. When I take out 5x from 20x, that leaves me with 4. Now remember, this step is not necessary. If you're able to skip this step, that's great. I haven't actually factored the entire expression yet. All I've done is change both of individual terms into products. So now we take our common factor 5x, and we multiply it by what we have left. Let's see, 5x times what is 5x squared? We already wrote that out, that is x. Maintain the structure of a sum. 5x times 4 is 20x, so our second term is 4. And we have successfully factored. Now, it's always a good idea to multiply to check. This one, let's just do in our heads. 5x times x, well, x times x is x squared, so 5x times x is 5x squared. So that already shows me that my first term is right. Plus, that shows me that I maintain my structure. 5x times 4, well, 5 times 4 is 20, times x is 20x. My structure was maintained. I'm good to go. All right, let's take a look at that second expression. This one is a trinomial. Just because it has 3 terms does not change anything about our work. So I'll go ahead and separate this. Here we go. Start with finding the GCF. Now, for those of you who reached the challenge portion of your IXL yesterday, you were asked to find the GCF of 3 terms. This is exactly why we do that. So let's start with the numbers. We have a 3, and a 15. Well, I know 3 only has 2 factors, 1 and 3. So it's really just, is 3 also a factor of 15? Yes, it is. So I know my GCF here is at least going to be 3. Now this has an x squared, this has an x, but there is no x here on 15. So I can't say that my GCF is 3x, because x is not a factor of all 3 terms. It's only a factor of the first 2. Excuse me. So my GCF here is 3. That's the only thing that I can factor out. Step 1 complete, we found our GCF. Step 2, let's factor out the GCF. So if I write these as products using the GCF, 3x squared is just 3 times x times x. 3x is just 3 times x. And 15 is 3 times 5. Notice how the only thing all 3 terms have in common is 3. All right, here we go. So writing each term as a product. The first term is 3 times, when I take 3 out, I'm left with x squared. Maintain the structure. This is minus, take out the GCF again from the second term. 3 times, when I take out 3, I'm left with an x. Maintain the structure. This is plus, and then again, 3 times, when I take out 3, I'm left with 5. Let's do a quick multiply to check here. 3 times x squared is 3x squared, minus 3 times x is 3x, plus 3 times 5 is 15. We're looking pretty good here. But I haven't factored it yet. This is still a difference in a sum. I want it to be a product. So the final step, pull out that GCF3, and what are we left with? Well, 3 times what gives me 3x squared? We have it right here. That's x squared. Maintain the structure. Minus 3 times what gives me 3x? We have it right here, just x. Maintain the structure. 3 times 5 gives me 15. And you have now factored this expression. You have turned it into a product. Let's do a quick multiply to check. 3 times x squared, that's 3x squared. That is my first term. Minus, so I know structure was maintained. 3 times x is 3x. So that's my second term. Plus, I know structure was maintained. 3 times 5 is 15. Smiley face, the check works out. All right, everyone. So in today's practice, I'm going to become a little midget here. In today's practice, you will be working on factoring out a GCF from both binomials and trinomials. So just please remember, the first step is exactly what we did yesterday. You're finding the GCF of monomials. If you did not do yesterday's practice, you are not ready for today's. So please make sure that you have completed yesterday's assignment prior to attempting today's. Tomorrow, we will just be learning more examples like this, so we're not learning anything new. And so because of that, today's IXL code, if you are struggling with it today, email me specific questions, maybe take a screenshot, maybe take a picture on your phone, send it to me, and I may not get back to you, but I will include examples that you struggle with in tomorrow's lesson. So tomorrow I will not be assigning anything new. Instead, I will be covering this kind of concept if we're struggling with it, because it is so crucial that we understand this before we can move on. All right, hope you have a wonderful day. Take care, make sure you are still sheltering in place, taking good care of your health, and I will talk to you all tomorrow.